Ooh, okay. So today we're going to get started on a new unit about triangles. We are going to do a little bit of note taking today, but it won't be very much. Today should be pretty simple. Tomorrow we're going to kind of go a little bit more in depth, and then next week we'll really get into it. But we will have time at the end of the day today to finish up the assessment from yesterday. I know I cut out halfway through class because of the internet dying at the school. Hopefully that won't happen again today. I am at home and that internet seems to be more stable. So those of you that weren't able to finish, I can still help you later today. But you will want something to write down some notes on. This one doesn't have too many. I think there are like 6, maybe 7 things you need to write down, but they're all pretty short. But we are going to be talking about triangles. So the first thing that everybody has to do is tell me how many triangles are on this page. Go. You have 10 seconds.
49.
One student claimed to have counted them last class. They said there were 126, but I don't actually know how many there are. I was just kind of messing around. But anyway, glad to see a lot of you are making guesses. Summer and Cohen, those are probably the worst guesses, though. Like, I know I'm not supposed to single students out when they get things wrong, but all right. And then you can count the triangles on this page too, but I don't want to do that either. So introduction, the actual thing we're going to talk about today is measures of angles and other stuff. Oh, that's right, Maddie. You told me about that. Do you have anywhere else you can write it down? Okay, then write it down somewhere else for now. I'll try to remember to get you in. I was hoping we'd be back in person by now, so I could just hand you a spiral, but we're still not. So we'll figure something out. But that works. Sorry, Miss Page. You do plenty of reading and writing for her. It's fine. All right. So as you can see, this page, this one you actually should be able to count the triangles on. Can anybody tell me how many triangles are here? Nobody ever takes it seriously when we're... Yep, you guys did a really good job. Okay. So nobody in my 8th grade math class can count except for Nolan, so that's a little scary. But all right. So triangles, as I'm sure you all know, so you don't necessarily need to write this down, are composed of 3 sides and 3 angles. For this red triangle, this is a side, this is a side, and this is a side. This is an angle, this is an angle, and this is an angle. Woo! 3 sides, 3 angles. That's what the tri means. Angles mean angle. The sum of the interior angles of a triangle is always 180 degrees. This is something that's worth writing down if you don't already know it. If you already know that, then you don't necessarily need to. I trust your judgment on this one. But that means that all of the interior angles, so interior angles, we're specifically talking about the angles inside the triangle. Interior meaning in. So all 3 of these will add up to 180, whatever they are. All 3 of these will add up to 180. And all 3 of these will add up to 180. And the next thing that my PowerPoint decided to jump ahead on a little bit is that triangles are usually defined by their largest interior angle. We'll look at that on the next page. So really the only thing you need to write down here, if you don't already know it, is that the sum of the interior angles of a triangle is always 180 degrees. Did I see? Hold on just a second. Yeah, okay. Need to fix attendance as people show up. All right. Okay, now let's look at the different categories of triangles. So we're going to categorize triangles in 2 different ways. We're going to categorize them by their angles, and then we're going to categorize them by their sides. Some of you probably already know the ones for the basic types that are categorized by their angles. So we have acute triangles, we have right triangles, and we have obtuse triangles. So acute triangles are triangles in which all angles measure less than 90 degrees. So as we can see up here, we've got a 40-degree angle, 75-degree angle, and a 65-degree angle. So in this case, we'd have 40 plus 65 plus 75, which if you plug that into a calculator does in fact equal 180. Nolan. Language. Do I need to take off chat for you two in your 4th grade level insults? Okay. fine. So acute triangles, if you, sorry, that was really distracting. Acute triangles, if you're having trouble remember them, remember that they're smaller than 90 degrees. They are cute because they're small. Small things are cute. Cute's in the word. Yeah. Right triangles, I think most of you already know these ones. They have one angle that measures 90 degrees. The angle that is a right angle is often drawn using just this little box, so it makes like a square. This just means it's a right angle, which means it has 90 degrees. I'm sure that most of you already knew that symbol before, but just in case you haven't seen it, this will always mean a right angle and 90 degrees. And then an obtuse triangle has one angle that measures more than 90 degrees. Question for everybody. That's actually exactly what I was going to ask, Nick. Is it possible, whoops, what happened there? Is it possible for a triangle to have more than one angle with 90 degrees or greater? Which is a question for everybody. See a couple of no's? That would be a square. So you are both correct. It is no. The exterior angles do add up to more than 180, and we'll talk about that later. But if we look at a triangle, so let's say I did make one with 90-degree angles. If I went 90 degrees this way, and then up, and then 90 degrees this way, these two lines would be parallel, so they'd never meet. So this is not a triangle. But more importantly, with our measures, if we have 180 degrees in every triangle, and we have two angles of 90 degrees, what's the third angle? It would have to be 0. And you can't have an angle of 0, and you have to have 3 angles for it to be a triangle. So you can't have more than one 90-degree or greater angle. And obviously, if they're bigger, right, 91 and 91, then you have 182, and you've already gone too big. So you can never have a triangle with more than one angle of 90 degrees or more. You could technically have a triangle that is 90 degrees, 89.9 degrees, and 0.1 degrees. But that would be a really, really, really long triangle. The angle on a straight line is a few different things. It's technically 0 and it's technically 180. So, you know, that's fun. Nick, did you have something to add? Oh, okay. All right. Does anybody need more time to write these definitions down? I think I talked long enough. All right, let's go to the next one. So the next thing is we're categorizing triangles by their sides. So we have scalene triangles, which is this one here. We have isosceles triangles, which is this one here. We have equilateral triangles, which is this one here. There will be a spelling quiz on these. So, you know, you got to make sure you know all the different. Really? This class isn't going to panic about it either? Oh, come on. I had to Google how to spell isosceles like 4 times when I was making this. There won't actually be a spelling quiz. Scalene triangles are a triangle with 3 different side lengths and 3 different angles. So in this triangle right here, we've got the side length that's in blue, the side length that's in green, the side length that's in purple. We have a 61-degree angle, 63-degree angle. Spoilers, this is a 56-degree angle. Isosceles triangles are a triangle with 2 congruent side lengths and 2 congruent angles. This is actually, it should say 2 or more, but I didn't want to make you all write that down. So it's at least 2. If they have at least 2 congruent sides and at least 2 congruent angles, then they are isosceles. So 2 or more. All right, those of you that are chatting a bunch, I know that some of this stuff is review, but trust me, by tomorrow it will not be review anymore. If not by the end of today. And then equilateral triangles are a special type of isosceles triangle. So it's a triangle with all 3 congruent sides and angles. In an equilateral triangle, all of the angles are always going to be 60 degrees, no matter what. That's because they're all the same. There are 3 angles, they're all the same, and they all have to add up to 180. So you do 180 divided by 3. So no matter what the side lengths are in an equilateral triangle, whether they're super, super, super short or super, super, super long, all of the angles are going to be 60 degrees. One other thing I do want to talk about while you all are writing down definitions is in an isosceles triangle, if you have the two congruent side lengths that are marked right here by these slashes, which I should also probably talk about those two, the angles opposite those are going to be congruent. So if I had an isosceles triangle that looked like this, where I have one side and one side that are congruent, this angle is congruent to this angle because they're opposite those side lengths. So opposite your congruent side lengths are congruent angles as well in isosceles triangles. And then for those of you that don't know already, when you have these little dash marks through the sides of a side length, that's a congruency mark. So basically what they're saying is that in this triangle, this side is congruent to this side is congruent to this side is congruent to this side. And in this one, since we have one that has one that has two, and one that has three, they're all different. So they all are different lengths. Okay. Anybody need more time on this side or slide? So the side length's too much. Okay. So this is just a quick little summary of all the different things we talked about. You can take a screenshot of this if you want it in your notes. You don't have to. I don't really care. It's up to you. But it is kind of a nice little collected version. So we've got equilateral triangle, isosceles triangle, scalene triangles, and then we've got acute, right, and obtuse. The congruency marks. So are we talking about these? So these are just called congruency marks. And you can do something similar with angles. So for instance, this one has two different angles that are congruent. So we might draw those like this. So they both have two lines. And then the angle that's not congruent just has one. So a lot of times these are different ways of saying whether things are congruent or not. Okay. So really quick check-in on your identification of triangles abilities. For triangles A, B, and C, tell me first, are they acute, right, or obtuse? And then are they, let's see if I can spell these, isosceles, scalene, or equilateral? Yeah, in private chat, Thomas, would be ideal. Here, I'll make sure for now. We'll turn it back to everybody in a second. That is correct, Maddie. Correct, Barb. Or wait. Hold on. Oh, I'm confused. I misread something. Daniel. Looks good. Thomas, yeah. So for each one, you should be able to pick one of these three words, acute, right, or obtuse, and one of these three words, isosceles, scalene, or equilateral. So each one, you can pick one of each. Daphne, that's correct. Maddie, that's correct. Oh. Lulu, that's correct. Sorry, I missed some chats in the middle there, so I'll go over them in a second in case you're not sure. Cohen, that's correct. Camden, I guess that's kind of correct. They're written up at the top though, so spelling wise. Lulu, double check that last one. Oh, there you go. You fixed it. Never mind. Camden, good. Eden, good. Penny, good. Cohen, that was right. Thomas, I think those are all right. Tate, I think those are right. Okay. I'm going to go ahead and start going through them a little bit. So for A, first thing we want to do is look at the angles. So the biggest angle here is angle B. And as we can see, it's a little bit bigger than 90 degrees. 90 degrees would be going straight up. It's leaning a little to the left. We know that this is bigger than 90. Bigger than 90 is obtuse. And then since our markings, we have this side only has one tick mark, this side has two, and this side has three. That means they're all different lengths, so this is scalene. So the first one is a scalene and obtuse triangle. The second one, we've got our little handy dandy right angle marked there with box. So we know that this is a right triangle, has a 90-degree angle. And then since we have two congruent side lengths and two congruent angles, we know that it is also isosceles. So this one is isosceles and right. And then the last one, all three of the angles are 60 degrees. That alone should give it away. But if it didn't, you've also got the little tick marks and all those other things. So the biggest angle is 60 degrees. That's acute. And of course, since all the side lengths and all the angles are the same, it is equilateral. So we have an acute equilateral triangle there. If this is confusing to you, if you don't understand what's going on here, you'll get some practice with it on the homework, but feel free to stick around and get help after class today. And Barbara, I would be happy to help try to clarify things for you. So the last couple things we're going to do is practice finding a missing angle. So we've already done this a tiny bit with your assessment from earlier in the week, but we'll go ahead and continue. So we're looking for this angle here that I'll label X. We have a 55-degree angle and we have this right angle here. So try to figure out, tell me what X is. Camden and Thomas, that is correct. Tate, that's correct. Maddie, that's correct. Nick, that's correct. So Aiden, all triangles, all the angles, or sorry, all the interior angles of a triangle always add up to 180 degrees. Lou, that's correct. Cohen, that's correct. Emmy, that's correct. This is actually a really high participation day. I like it. Aiden is correct. Nolan is correct. Daphne is correct. All right, we'll go 20 more seconds, and then we'll start talking about it. Okay, so since we know that all the angles in this triangle add up to 180 degrees, and take our 180, we're going to subtract our right angle, which is 90 degrees, and then we're going to subtract our given angle, which is 55 degrees. When we subtract these out, 180 minus 90 is 90, 90 minus 55 is 35. So X is 35 degrees. Now, tomorrow I'm going to start doing these, setting them up as algebra expressions, and there'll be a reason for it that I'll talk about tomorrow. But if we're going to do that, what we would do is we just do it the other way. So we'd say 90 plus 55 plus X equals 180. And then we just solve this for X. But again, this will make more sense tomorrow when we look at some problems that you actually need to do it. For today, though, the last two problems are right here. You want to find the missing angles A, B, C, D, and E. It will help to identify what type of triangles these are in terms of their scalene, isosceles, or equilateralness, because that will give you some hints. Camden, that's correct. Nick, remember a triangle also has to have three sides for the email that you sent me. Nick, that's correct for A and B. Tate, which angle is that? Summer, those are options, but that's not correct in this case. It has more than 3 sides. Thomas, that's good. Ah, okay, I'm losing a lot of you. There's too much. Too much. Okay, so first off, who can tell me what kind of triangle is the blue one? It is isosceles. That means that it has 2 congruent side lengths and 2 congruent angles. So the thing you have to realize about this one, since this side and this side are congruent, the opposite angles are also congruent. That means that A and B have the same measure, which means all we have to do is say 180 minus 40. This gives us how much is left between the two of them, which is 140. And since they're the same, we can just divide this in half. So A and B are both 70 degrees. A and B. C, D, and E, this one, again, it helps if you identify the type of triangle. This is an equilateral triangle because all 3 side lengths are the same. And since it's equilateral, all 3 side lengths and all 3 angles are the same. So you just need to take 180, divide it by 3, and you'll get 60 degrees for each of these angles. So remember that all equilateral triangles are always going to have all of their angles measure 60 degrees. So really, if you memorize that part, you don't even need to do math here, but you can also just take the math approach. Either one of those is just fine. So I haven't gotten around to posting it up on, I set the wrong date for the Google Classroom because I kept pushing things back for the test. So today, your homework is either the math-based task Angles in Triangles or IXL 07. And I will fix the post in just a second, make sure it's actually up there. But if you haven't finished the test from Tuesday, please stick around. We can help you through that. I know I disconnected halfway through helping some of you yesterday. So I will stick around and help anybody with that. But otherwise, you guys are good to go. Have a good rest of your day, and I will see you tomorrow.